3.4, solving quadratic equations by factoring. What we're looking at here, folks, is we're going to look at examples where we need to solve the quadratic equations. Just like we've always been doing in this unit, we need to remember that when we have to solve a quadratic equation, one side will always equal 0. Because essentially, when we're solving, we're finding solutions, such as the x-intercepts, the zeros, the roots, the solutions. So, looking at the first problem, and the second problem, and the third problem, you can see here we have three different ways of looking at the problem. In the first one, we have it in factored form equal to 0. Essentially, that's always what we're looking for. So we can find the zeros. What makes those brackets 0? Well, x will equal -3 from the first bracket, and x will equal 5/2 from the second bracket. And then we put them in order, and we can write it as one or as two separate ones. I'm good with either or. In a question like this, you all should know how to solve this. Last year, or even in grade 9, you learned how to solve questions like this. When x squared equals 36, that means x is equal to plus or minus the square root of 36, which is equal to plus or minus 6. So these are our two answers for a question like this. Oftentimes, when we have x squared, we're going to have two solutions. X squared minus 49 equals 0. There are two ways to do this particular problem. The first way is to make 49 move over, just like in part B. And then we take this plus or minus square root of 49, which means you'll have x is equal to plus or minus 7. Now, that's one way of approaching this question. Another way is you could have factored the left side, x minus 7 times x minus 6, x minus 7 times x plus 7 equals 0, and you would find the solutions for x. Those solutions would be the same solutions that we have in blue. Okay, now, part D, let's look at another problem. Here we go again, and another one. What do we do with this? Well, when we have a question that looks like this, you have to approach it by factoring it. Don't forget that one side must equal 0. We will factor it by looking at the product and sum. What two numbers multiply to give us -20 and add to give us 8? Think about it. Multiply to give us -20 and add to give us 8. Well, the numbers are going to be x plus 10 and x minus 2. That means that x will equal -10 or x will equal 2. In the next one, we have x squared minus 7x equals -10. We move the minus 10 over, it becomes plus 10, so we have x squared minus 7x plus 10 equals 0. That means we will factor what two numbers multiply to give you positive 10 and add to give you -7. That is -5 and -2. We factor it, and then we find the zeros. X equals 2 and x equals 5. Okay, moving on. Example 2. Determine whether the given number is a root of the quadratic equation. So, when you're asked a question like this, whether the given number is a root, it means that we're trying to find out, does this, when we plug it in, equal the other side? So again, that has to do with that left side, right side we talked about earlier in the previous section. So we need to find the left side equals the right side. So we're going to check to see if x equals -2 is part of that equation. So we're going to check it in the equation. So the left side and the right side. The left side of the equal sign is -2 squared plus 6 times -2 minus 16. Does that equal the right side? Well, when we plug it in, we find out that the answer is -24. So no, unfortunately, left side does not equal right side, and therefore, x equals -2 is not a root. Moving on, let's look at another problem exactly like this. Part B. x equals 1 in this equation. So this one's a little harder because we have strange things on both sides. That's okay, folks, because we're going to check x equals 1 in the equation. And left side, right side. Left side is 3 times 1 squared plus 7 times 1. The right side is 12 minus 2 times 1 squared. So we have 3 plus 7, which is 10, and 12 minus 2, which is also 10. Therefore, left side equals right side. And since left side equals right side, we can say that x equals 1 is a root. All right. And just as a funny little note, my little trademark checked that we've equaled it. So we've checked that they're equal, and that makes us happy. All right. Keep moving. Example number 3. Solve by factoring. Verify your solutions. So what we need to do with these type of questions is to factor it. A question like this, you can't factor, folks. What we want to do is expand it and then move everything to one side. Once we do that, we move to the side where x squared is positive. Why do we do that? Because it's much easier to factor when the x squared is positive. So move to the side where x squared is positive. We have x squared plus 10x. Means that we can common factor, and that's the easiest type of factoring, common factoring. And then once we common factor, we can find what x values they are. X equals negative 10 for this inside here, and x equals 0 for this x right here. So either of these numbers will make this equal to 0. Now, we need to verify the solution because that's what it says. So we're going to check x equals negative 10. We plug it in the left side. We plug it in the right side. And we find out that left side equals right side. Check x equals 0 in the equation. Left side, right side. We plug it in and we find out that left side equals right side as well. So therefore, we know that x equals negative 10 and 0. These are the solutions. All right, moving on to another one. Part B. So we have a question like this. And what we need to do, folks, is factor this. Expand it first. This is what I recommend you do. Expand. Expand again. And then what we're going to do is once we've expanded it is to collect like terms. We're going to move everything this time to the left side. X squared plus 6x minus 27 is equal to 0. So we need to factor it. So what two numbers multiply to give you negative 27 and add to give us 6? That is x plus 9 and x minus 3 equals 0. And x plus 9 means that it's x equals negative 9. And for x minus 3, x equals 3. And what we have to do, folks, is check x equals negative 9. Left side, right side again. And we see that left side equals right side. Wonderful. We check x equals 3 now. And again, we plug in x for 3 with 3. And we end up getting left side equals right side again, folks. We've checked that it's equal. And therefore, the solutions are x equals negative 9 and x equals 3. All right, almost done, folks. Let's look at another example. 2 times x plus 1 times x minus 4 is equal to 4x minus 2 times x plus 2. Again, folks, what we need to do is expand it. Don't forget to expand it by expanding the brackets first by foiling. We expand again with the number on the outside, and collect like terms, this time moving everything to the right side. As we do, and now we're going to common factor. That's right, we need to common factor. And then we're going to see what two numbers multiply to give you negative 4 and add to give you 3. That is 2 times x plus 4 and x minus 1, which are, and then what you have to do is check the solutions. And I'm going to leave that for you, folks. Okay, one more problem. Here it is. This is a word problem. And looking at the word problem, it talks about a dolphin. But specifically, what we're looking at is a horizontal distance, h at d, and we're looking at a vertical distance, okay? H and D is the horizontal distance from it, and the height that it is, so the vertical distance. So the vertical height plus the horizontal distance, we're looking at this. Now, we want to know when the dolphin will reach a certain height. So this is not asking for a maximum, folks, but when will it reach a certain height? That means that what we have to do, let's look at what this is actually explaining. So we have a height and we have a distance. We want the dolphin to reach 1.8 meters. When does it reach 1.8 feet? When does it reach it? Well, at a certain, it jumps out of the water at a certain, and then it jumps up, reaches the 1.8, goes past it, comes back down, and then reaches 1.8 again on its way down before it goes back in the water. So, with this understanding, what you need to do is use the equation to our benefit. That is, we're going to set h at d equal to 1.8, and that equals the equation. Now, I know it's tough with decimals, but I promise you with the decimals you'll be able to get nice answers. We're going to take out 0.2, and we get d squared minus 10d plus 9 equals 0. Now, don't forget that when you divide out 0.2, you're dividing it out of here and out of here. So that's how we ended up with these values. Don't forget to use a calculator when you're dealing with decimals. So we have d squared minus 10d plus 9. And then you're going to factor this inside, and we get 0.2 times d minus 9 and d minus 1 is equal to 0. So two numbers multiply to give you 9 and add to give you negative 10. That's negative 9 and negative 1. D is equal to 9 and D is equal to 1. So that means the dolphin will reach a height of 1.8 feet at 1 foot and 9 feet. So basically, it'll be at 1 foot at this point right here on its way up, and then at 9 feet later from where it jumped out of the water, so 1 foot over, it'll be at 1.8, and then 9 feet from when it jumped out of the water, it will also reach 1.8 feet. Okay, well, that's the end of the lesson, folks. Hope this helps. Have a numerical day.